Good day. Today we're going to do the notation for differentiation. If we have, for example, y equals ax squared plus bx plus c, and my equation starts with y, and I have to derive with difference to dx, I will write my notation as dy over dx. If my equation starts with v equals pi r squared h, and I need to derive with reference to r, then my notation will be dv over dr, or if I derive with reference to h, my notation will be dv over dh. I can also write my notation as y with a little 1 at the top there, or a v with a little 1 at the top there to show or indicate first derivative. Also, the function derivative with reference to x, or the function derived with reference to r. You can also say the gradient of the tangent, and all of these notations mean you are now going to differentiate. So to continue, now we're going to do differentiation techniques, and the first one is the power function. There your equation starts y equals, and you will derive with reference to x, and x is also a base number. So what you do, you take the exponent of the x, you multiply it to the front, and you minus 1 from it. So indicate first dy over dx equals 2 times 3 is 6x, 2 minus 1 is 3 minus 1 is 2, plus 6 minus, this is x to the power of 0, multiply the 0 to the front, minus 1 from it, will just be 0, or you can just leave out that term completely. If I go to another term, you must always make sure that your equation is in its simplest form before you differentiate. So I can rewrite this equation as y equals x to the minus 3 plus x to the exponent of a half. Now everything is on the same line, and I can start my differentiation. So firstly, I indicate dy over dx equals, take the exponent, multiply it to the front, subtract 1 from it. So minus 3 minus another one is minus 4, plus take the exponent, multiply it to the front, subtract 1 from it. A half minus 1 is minus a half. Now I can just make it look better by changing all the negative exponents into positive exponents. So my final result will look like this. Minus 3 over x to the exponent plus 4 at the bottom of the line, plus 1 over 2 at the bottom, the root of x. And that will be deriving using the power function method. Now we're going to derive an exponential function. When deriving an exponential function, x will be an exponent now, not a base number. So when you derive an exponential function, you do the following. First, you indicate by writing your notation down, dy over dx. Then I write down the equation as is. Then you multiply by the ln of the base number there is 2. Thereafter, you multiply by the derivative of your exponent. So if I derive this, 1 multiplied by 3 is 3. 1 minus 1, the x disappear. And this will be your final derivative. You can, of course, write the number in front. If you do have another number in front or another variable in front, you just do the following. First, you indicate dy over dx. You write the whole equation down as is. My whole exponent, x is an exponent there, multiply by the ln of the base. In this case, the base is only the e value. Then I have to multiply by the derivative of this exponent, which is 2 to the front. 2 minus 1 is 1, so I'll get 6x there. So you can keep it in a bracket if you want, and then 3 times 6 will give you 18x times e to the 3x squared, and that will be your final answer. Now we're going to do differentiation of a log or a ln function. So it will clearly be indicated if there's a log and there's no number, the base number there would be 10. If another number is given, you will use the given number. Or the ln of a function. So when I derive a log or a ln function with log, you first indicate dy over dx, then this becomes 1 over x, the ln of whatever the value is there. That will be your final resultant. Or when you get to a ln function, you indicate dy over dx. The ln of something will become 1 over that whole something there. But then you have to multiply by the derivative of this, which is 2 to the front, 2 times 3, 6. 2 minus 1 is 1, which will be 6x, and that is the differentiated value of this. Now only you can simplify or rewrite it in the form and cancel out. So my final answer will be then just 2 over x. So the next function that we're going to derive is trigonomical functions. So there you would use your formula sheet, and you will see that sine will become cos when you differentiate, and cos will become minus sine, for example, when you differentiate. So if I have to derive y equals 3 sine 2x, I first have to indicate dy over dx. Then the 3 stays there. Sine will become cos of the angle can never change to x, but thereafter I must multiply by the derivative of this angle, which is 2. So that will give me 6 cos 2x. Remember, this angle can never change. It has to stay the same. And that will be my final answer. If I go to the next one, y equals 2 cos 5x, dy over dx then becomes 2. Cos becomes minus sine, so bracket minus the sine. The angle can never change. You keep it 5x, but thereafter you must multiply by the derivative because it's more than 1x. The differentiated value there is 5, so this will give you minus 10, the sine of 5x, and that would be the differentiated value for that trigonomical form. So the next function that we're going to derive is an inverse trig function. There we will also use your formula sheet. For example, the inverse sine of x derived will give you 1 over the root of 1 minus x squared. So if you have an equation to derive, you write it down first, you indicate dy over dx. Now you have to see inverse sine will give you 1 minus x squared, but my x is 3x's, so I need to put 3x's in there, and then afterwards I must multiply by the derivative of the 3x, which is 3. So my final answer will be then 3 over the root of 1 minus 3 squared is 9 x squared, and that will be the result of my